Artificial intelligence has been a hot topic for some time, and I will introduce basic concepts as simply as possible. Rather than repeating the definitions from the internet, I decided to change those into questions. I hope this makes concepts easy to understand. Let's start with artificial intelligence. The question will be, how can we build smart machines that mimic human intelligence? I like another definition, intelligence being created or simulated by human beings through technology. Here, you can see a Venn diagram. All concepts mentioned in this presentation can be considered a subset of AI. Here, you see a chess machine, a mechanical automaton capable of winning games against humans, only for the last moves of a game, which was invented in 1912. The term AI was first coined much later, in the 1950s. So, AI is not a new concept, but the nature of artificial we can create has changed dramatically with the technical advances in recent years, mainly computational. Let's continue with machine learning. Machine learning, in short ML, is a subset of AI. I came up with this question to explain it: how can we build machines that learn a task by using data? So, the behavior of a machine changes by its input, the machine learns from data and applies its learning. By the way, intelligence can also be defined as quickly learning and applying new knowledge, right? So, ML requires machines to learn from data. An example would be a robot learning how to dance by continuously processing sensors and moving relevant motors. A machine can learn to predict which customers will churn or not pay their bills, etc. Let's go a bit deeper and discover how machines learn. Let's start with supervised learning. In supervised learning, we have questions and answers. Answers are called labels. Features selected, and a label that says this customer has churned, will help us to teach machine to predict whom else will churn. Okay. But what is feature extraction? Our databases have all transactional history and customer information. So, a domain expert comes with an Excel file, dictionary, that will ask some questions for your teams to extract some information that, in their experience, can help us predict who will churn or not pay their bill. For credit risk, an example of a feature would be how many times this customer has paid his bill late in the last 6 months. Answers to every question is encoded into a vector, which is called feature vector. There is one more thing that we need to train the machine: label. Labels indicate customers who churned already, or customers who had not paid their bills. We provide both feature matrices as well as labels to the machine learning algorithm to train our model. We built the model in yellow there. But how can we be sure that our model is the best possible? We evaluate our model with a separate test data, which we know the right answers. If it does not perform as we expect, either we change the features extracted or ML algorithm with its parameters, until we are satisfied with the model performance. When a customer contacts our call center, we extract same features we used for model training, fed that vector into the predictive model, and we act on the label we receive with its probability. Normally, operator has different options to present based on model output. That's all for the supervised learning. In summary, we have some experience encoded in our data. We train machines to understand that experience and help us create desired outcomes. Unsupervised learning is more straightforward to explain. The machine detects patterns within data, all by itself. There are no labels. An example would be customer segmentation for insurance rate making. Detecting anomalies and outliers and fraud detection can also be a use case for unsupervised learning. Let's move to deep learning. Deep learning is a recent development that requires huge data sets and a good amount of computing power, both CPU and GPU. Our question is, how can we build machines that use multi-layer deep artificial neural networks to learn complex tasks and abstract concepts using large data sets? Please recall the machine learning slide. I mentioned that a domain expert using a dictionary to build a feature matrix to train the machine learning algorithm. In ML, we have an idea of which features we should be extracting. But in deep learning, we cannot explain features of a cat to a machine to distinguish it from a dog on each photograph. So, we use massive data and let the machine learn, detect and extract features by itself. Let's introduce self-supervised learning. Here, we give the machine the input data. The machine, as it reads the symbols, makes guesses for the following symbol. If it fails, it learns, so and tries again. It goes until it can guess the correct symbol, and moves ahead for the next symbol. Indeed, this is how large language models are trained. Model is trained with huge number of statements, learns meaning of each word, statement as well as sentiment, and starts having meaningful conversations with us, by just predicting next word to say each time. The last learning type I will talk about is reinforcement learning. Please check this picture, and you will have an idea. The dog is trained to fetch the ball and receive the treat. In case of the machine, it interacts with the environment, and correct decisions awarded bad ones have penalties, so it learns. I put a red circle on the Venn diagram to show that reinforcement learning can be applied both on machine learning with known features and not large data, as well as with deep learning using deep artificial neural networks. Some examples would be ML-based stock trading models, or adversary deep learning models playing Go with each other and learning the game. We have the usual suspects here. Gen AI uses the knowledge machine learned during training to generate new and unique artifacts. My question is, how can we build machines that generate new, original content like images, text, or music by themselves? As we discussed earlier, in deep learning, machine extracts features of a cat to distinguish it from a picture. It has an idea of what a cat would be, and it can create a cat picture based on that knowledge. Sometimes, it does not look like a cat, but remember, it uses its internal knowledge to separate the cat from other animals. We cannot know which features it is looking at and reflecting in its output, we cannot even explain it for our understanding of a cat. Here are some examples of generative AI services. Please play with them if you can find some time, ask questions to see how intelligent they are, but do not trust their response. ChatGPT is just guessing next word to say. Lastly, I will talk about artificial general intelligence. This is an abstract topic, to me at least. No known AI exists at this time. Question is, if it exists, will we be able to detect it? I formulated this question to describe it as I understand. How can we build machines that can perform any intellectual task a human can perform, including problem solving? Since we do not know how it can be built, I put it to cover machine learning, deep learning, generative AI and artificial intelligence in our Venn diagram. Opportunities looks like infinite. If we can build such a machine, probably we will see some scientific breakthroughs with it. I depicted it as a human brain in silicon to represent artificial general intelligence. Let's continue with the main session.